Welcome to K.SREEKUMar tuition, continuation of Laplace transform. Today I am going to discuss inverse Laplace transform. Inverse Laplace transform. See, we know that Laplace of 1 is equal to 1 by s. Laplace of 1 equal to 1 by s. Then Laplace inverse of 1 by s is equal to 1. Laplace of 1 is equal to 1 by s. Then Laplace inverse of 1 by s is equal to 1. Next, Laplace of t raised to n is equal to n factorial by s raised to n plus 1. Then Laplace inverse of 1 by s raised to n plus 1 is equal to t raised to n divided by n factorial. Laplace of t raised to n. Laplace of t raised to n is equal to n factorial by s raised to n plus 1. Then Laplace inverse of 1 by s raised to n plus 1 equal to t raised to n divided by n factorial. Still, there is another section of this formula. Laplace of t raised to n minus 1 is equal to n minus 1 factorial divided by s raised to n. So, Laplace inverse of 1 by s raised to n is equal to t raised to n minus 1 by n minus 1 factorial. Okay, you have to do this formula or remember this formula. Laplace inverse of 1 by s raised to n is equal to t raised to n minus 1 divided by n minus 1 factorial. Laplace of 1 equal to 1 by s, then Laplace inverse of 1 by s is equal to 1. Laplace of t raised to n is equal to n factorial by s raised to n plus 1. So Laplace inverse of 1 by s raised to n plus 1 equal to t raised to n by n factorial. Or we can say Laplace of t raised to n minus 1 equal to n minus 1 factorial by s raised to n. Then Laplace inverse of 1 by s raised to n equal to t raised to n minus 1 divided by n minus 1 factorial. Okay. Next, Laplace of e raised to at. Laplace of e raised to at equal to 1 by s minus a. So, Laplace inverse of 1 by s minus a equal to e raised to at. Okay. Laplace of e raised to at equal to 1 by s minus a. Then Laplace inverse of 1 by s minus a equal to e raised to at. And again, Laplace of e raised to minus at equal to 1 by s plus a. Then Laplace inverse of 1 by s plus a equal to e raised to minus 80. Laplace of e raised to minus 80 equal to 1 by s plus a. Then Laplace inverse of 1 by s plus a equal to e raised to minus 80. Okay. Next, Laplace of sine 80 equal to a divided by s square minus a square. Laplace of sine 80 equal to a divided by s square minus a square. Laplace of sine 80 equal to a divided by s square plus a square. So we can write Laplace inverse of 1 by s square plus a square equal to sine 80 divided by a. Sine 80 by a. Laplace of sine 80. Laplace of sine 80. Laplace of sine 80 equal to a by s square plus a square. Then Laplace inverse of 1 by s square plus a square equal to sine 80 by a. Next, Laplace of cos 80. Laplace of cos 80 equal to s divided by s square plus a square. Then Laplace inverse of s by s square plus a square equal to cos 80. Okay. Laplace of cos 80 equal to s by s square plus a square. Then Laplace inverse of s by s square plus a square equal to cos 80. Okay. Next, Laplace of sine h 80. Laplace of sine h 80 equal to a divided by s square minus a square. Then Laplace inverse of a by s square minus a square equal to, or we can write Laplace inverse of 1 by s square minus a square equal to sin h at divided by a. Laplace of sin h at equal to a divided by s square minus a square. Then Laplace inverse of 1 by s square minus a square equal to sin h at divided by a. And again Laplace of cos h at equal to s divided by s square minus a square. Then Laplace inverse of s divided by s square minus a square equal to cos h at. Okay. Next, Laplace of e raised to t and f of t equal to Laplace of e raised to t into f of t equal to phi of s minus a. Then Laplace inverse of s minus a equal to Laplace inverse of phi into s minus a. Laplace inverse of phi into s minus a equal to e raised to t f of t. Okay, next Laplace of t f of t. Laplace of t f of t equal to minus d by ds of phi of s. Then Laplace inverse of minus d by ds of phi of s is equal to t f of t. T f of t. 1. Here from this 11 formulas, see Laplace of 1 is equal to 1 by s. Then Laplace inverse of 1 by s is equal to 1. Laplace of t raised to n equal to n factorial by s raised to n plus 1. Then Laplace inverse of 1 by s raised to n plus 1 equal to t raised to n by n factorial. Similarly, these all both are equal. Laplace of t raised to n minus 1 equal to n minus 1 factorial by s raised to n. Then Laplace of 1 by s raised to n equal to t raised to n minus 1 divided by n minus 1 factorial. Laplace of e raised to t 1 by s minus n. Laplace inverse of 1 by s minus n equal to e raised to t. Similarly, Laplace of e raised to minus a t equal to 1 by s plus a. Then Laplace inverse of 1 by s plus a equal to e raised to minus a t. Next, Laplace of sin a t. Laplace of sin a t equal to a divided by s square plus a square. Then Laplace inverse of 1 by s square plus a square equal to sin a t divided by a. And again Laplace of cos a t equal to s by s square plus a square. Then Laplace inverse of s by s square plus a square equal to cos a t. Next, Laplace of sin h a t equal to a by s square minus a square. Then Laplace inverse of 1 by s square minus a square equal to sin h a t by a. Laplace of cos h a t equal to s by s square minus a square. Then Laplace inverse of s by s square minus a square equal to cos h a t. Next, Laplace of e raised to t into f t equal to phi of s minus n. Then Laplace inverse of phi of s minus n. Phi of s minus a equal to e raised to t into f of t. Next, Laplace of t f of t equal to minus d by ds of phi of s. Then Laplace inverse of minus d by ds of phi of s equal to t of t. Okay. Okay. Find the inverse Laplace transform of question number 1.
S square plus
S square plus
2s plus 5
2s plus 5.
the whole divided by s cube.
We have to find out Laplace inverse of s square plus 2s plus 5 divided by s cube. Okay. That means we can write Laplace inverse of s square by s cube, 2s by s cube and 5 divided by s cube. Okay. That is Laplace inverse of s square by s cube means 1 by s plus 2 out of Laplace inverse of 1 by s square plus 5 out of Laplace inverse of 1 by s cube. See, Laplace inverse of 1 by s raised to n is equal to Laplace inverse of 1 by s raised to n equal to t raised to n minus 1 by n minus 1 factorial. Okay. By using this formula, we can do these problems. Laplace of inverse of 1 by s is equal to 1. Laplace of 1 equal to 1 by s, then Laplace inverse of 1 by s is equal to 1. Okay. Plus 2 into Laplace inverse of 1 by s square equal to t raised to n minus 1, 2 minus 1 by n minus 1 factorial, 2 minus 1 factorial. And again 5 into Laplace of 1 by s raised to n equal to t raised to n minus 1, t raised to 3 minus 1 by n minus 1 factorial, 3 minus 1 factorial. That means 1 plus 2t by 1 factorial means 1, but we can delete that then. 1 plus 2t plus 5 into t raised to 3 minus 1, t square by 3 minus 1, 2 factorial, 2 factorial means 2, 1 into 2 equal to. So we can say that Laplace inverse of s square plus 2s plus 5 divided by s cube is equal to 1 plus 2t plus 5 by 2 t square. That is its answer. Okay, ready? Next, read the second question. Find the Laplace inverse transform of
4s plus 5
4s plus 5
divided by s plus 1 the whole square into s minus 2.
Yes. We have to find out the inverse Laplace transform of 4s plus 5 divided by s plus 1 all square into s minus 2. We have to determine Laplace inverse of 4s plus 5 divided by s plus 1 the whole square into s minus 2. Okay. Then before doing this problem, we have to convert this function into partial fraction. A by this is equal to partial fraction, that is 4s plus 5 by s plus 1 all square into s minus 2 equal to a by s plus 1 plus b by s plus 1 the whole square plus c by s minus 2. Before converting the function into inverse Laplace transform, we have to find out the partial fractions of the term. Then 4s plus 5 by s plus 1 the whole square into s minus 2 equal to a by s plus 1 plus b by s plus 1 whole square plus c by s minus 2. Take its LCM. That is 4s plus 5 by s plus 1 the whole square into s minus 2 equal to s plus 1 the whole square into s minus 2 upon a into s plus 1 into s minus 2 plus b into s minus 2 plus c into s plus 1 whole square. Okay. Then we can cancel this denominator. That is 4s plus 5 equal to a into s plus 1 s minus 2 b into s minus 2 plus c into s plus 1 whole square. Okay. Then we have to determine the values of arbitrary constant a, b and c. So put s is equal to minus 1. Put s equal to minus 1 means this term becomes 0 and also this becomes 0. Then 4 into minus 1 minus 4 plus 5 equal to minus 1 minus 2 minus 3 minus 3b. Then 4 minus 4 plus 5 equal to 1 equal to minus 3b. then b equal to minus 1 by 3. Okay. And again after that put s is equal to 2. Put s equal to 2. Then a and b becomes 0. This 0 and this 0. 2 into 4, 8. 8 plus 5 equal to 8 plus 5 equal to 2 plus 1, 3. 3 square, 9, yes. Therefore, s equal to 13 by 9. Okay. And next minus 1 plus 2 is or. Equate the coefficient of s square. Equate the coefficient of s square. Equate the coefficient of s square. Here coefficient of s square means 0. Here the coefficient expand this term s into s square. So we can say that coefficient of s square equal to a. Here there is no coefficient of s square. Here also s square. So we can write a plus equals 0. Then and this is equal to 9 c 9 c. So c is equal to 13. No. A plus c is equal to 0. Then a equal to minus c. Therefore the value of a equal to minus 13 by 9. Okay. But that is b is equal to minus 1 by 3 and c equal to 13 by 9 and a equal to minus 13 by 9. Okay. b equal to minus 1 by 3 and c is equal to 13 by 9 and a equal to minus 13 by 9. Okay. Then we have to substitute this value in this equation, that is 4s plus 5 by s plus 1 the whole square into s minus 2 equal to 4s plus 5 by s plus 1 the whole square into s minus 2 equal to a. The value of a equal to minus 13 by 9 by s plus 1. And b equal to minus 1 by 3 by s plus 1 whole square. And c 13 by 9 by s minus 2. Okay. Then we have to determine the inverse Laplace transform of the given function. That is inverse transform, Laplace inverse of 4s plus 5 divided by s plus 1 the whole square into s minus 2 equal to, that is minus 13 by 9 into Laplace inverse of 1 by s plus 1 minus 1 by 3 into Laplace inverse of 1 by s plus 1 whole square plus 13 by 9 into Laplace inverse of 1 by s minus 2. Okay. Laplace inverse of 1 by s plus a equal to e raised to minus 80. Then Laplace inverse of 1 by s plus 1 equal to e raised to minus t. So we can write minus 13 by 9 into e raised to minus t. Okay. And this is 1 by 3 into Laplace inverse of s plus 1 whole square. So that means we can write e raised to minus t into Laplace inverse of 1 by s square. Laplace inverse of 1 by s plus 1 whole square equal to e raised to minus t into Laplace inverse of 1 by s square. And then 13 by 9 into Laplace inverse of 1 by s minus 2, that is equal to Laplace inverse of e raised to 80 equal to 1 by s minus a. Therefore Laplace inverse of s minus 2 equal to e raised to 2t. Okay. Then Laplace inverse of 1 by s square, we can using this formula 1 by s raised n equal to t raised to n minus 1 by n minus 1 factorial. So this final result is equal to, I can write this value here. Therefore final result equal to minus 13 by 9 e raised to minus t. And this is equal to t raised to n minus 1. That means t raised to 2 minus 1 t by 2 minus 1 factorial. T by 2 minus 1 factorial means 1 factorial 1. But this Laplace inverse of 1 by s square equal to t. Laplace inverse of 1 by s square equal to t. So we can write minus t e raised to minus t by 3. Minus t e raised to minus t by 3. Laplace inverse of 1 by s square means t raised to n minus 1 by n minus 1 factorial. But t raised to 2 minus 1 means t raised to 1 by 1 factorial. 1 factorial means 1. Or you have to remember Laplace inverse of 1 by s square is always equal to t. So minus t e raised to minus t by 3 plus 13 by 9 e raised to 2t. That is the final answer. . Okay. Yes, next question. Third question.
Third question. S plus 8
S plus 8
the whole divided by S square plus 4S plus 5.
Find the Laplace inverse of S plus 8 divided by S square plus 4S plus 5. Laplace inverse of S plus 8 divided by S square plus 4S plus 5. We can factorize this term 4, 5, 1, no, there is no possible. So we can write Laplace inverse of S plus 2 divided by S plus 2 whole square plus 1 plus 6. Okay. That is S plus 8 equal to, we can write Laplace inverse of S plus 8 equal to, that is Laplace inverse of S plus 2 plus 6 divided by S plus 2 whole square plus 1. Okay. Then we can factorize this term equal to Laplace inverse of S plus 2 by S plus 2 the whole square plus 1 plus Laplace inverse of 6 divided by S plus 2 the whole square plus 1. Okay. That is Laplace of S plus 2 by S plus 2 the whole square means e raised to minus 2t into Laplace inverse of S by S square plus 1. Okay. And again plus 6 out of Laplace, this is equal to e raised to 6 out of Laplace inverse of 1 by S plus 2 the whole square means e raised to minus 2t into Laplace inverse of S square plus 1. Okay. This is Laplace inverse of S by S square plus 1. This is Laplace inverse of 1 by S square plus 1 equal to e raised to minus 2t into Laplace inverse of S by S square plus A square means cos 80. So we can write this is A means 1. So this is equal to cos t. And again 6 e raised to minus 2t into Laplace inverse of 1 by S square plus A by S square plus A square means sin 80 by A. Here A is equal to 1. So we can write that is sin t. So the final result of Laplace inverse of S plus 8 divided by S square plus 4S plus 5 equal to e raised to minus 2t out of cos t plus 6 sin t. Clear?
Okay.
Any doubts?
No.
Next portion we will continue in next class or in next video. Thank you.